Hello students, we are here today to discuss the Physics K-CET 2024 question paper along with the key answers. I am Arun Shidling from Gurudev PU Science College. So let us begin with the discussion of key answers. To begin with, I have question paper D2 series with me, and the first question comes out to be an induced current 2 ampere, and this comes from, as you people know, it comes from electromagnetic induction chapter. The formula is Faraday's law, and substituting we would get the answer to be option B. And next, going to the next question, that is the second one. It's from the chapter electromagnetic induction once again, which involves mutual induction in that. And mutual induction, as we know, mutual induction of any coil is not dependent, does not depend anywhere with time. So if it does not depend anywhere with time, then it should remain constant with time. So our right option would be option C. So let's move to the next part of the questions. Next question, it's question number 3. This is from AC chapter, and they are asking you have to find out a better tuning circuit. And obviously we have to take quality factor into consideration. Quality factor formula is 1 divided by R root LC. By seeing this, we have to understand that only the option which has L greater and C lesser should be the right answer, and the right answer should be option D. Yes, moving to the next question now. The next question is from which chapter? AC, alternating current. And what they are asking us, find out what's the relationship between frequency and capacitance. As we already know that we can write the relationship with the help of capacitive reactance, which I would directly put it right in front of you, that this would be F is inversely proportional to 1 by root C. Using this equation, we can clearly mention or say that the right option would be C option for this, that is this one. Okay. Next, moving to the next question. Next question is again from alternating current chapter. As we can see, 3 questions are from alternating current chapter. In this, they are asking which region or which frequency point circuit is capacitive. At which frequency point circuit is capacitive, we can clearly notice that for capacitive, we need to have XC greater than XL. So find the region in which XC is greater. I can see that in this region here, XC is greater compared to all other values. Here R and XL are same, XC is greater. So that's why it is the point A where we have greater frequency. So the right option will be C option. Yes. Now let's move to the next part of the questions. Yes. Next question we are having from electromagnetic waves chapter, that's right in front of you. So here they are asking us to calculate this one for perfectly reflecting surface. So perfectly reflecting surface, why I am highlighting that, I will let you know later. So perfectly reflecting surface, and we already know from this chapter that pressure radiation. So radiation pressure will be equal to P is equal to I divided by C. We know pressure can be written as force divided by area, and which is equals to I divided by C. If I try to write force, so this force will be I divided by I into A divided by C. Now next to this, as we can see, it is perfectly reflecting surface. So what happens? The force what we are getting is just for what? Action. There is no reaction consideration in this. So if I consider the reaction also of this one, it has to become twice. So my right option would be for this one, A option. Yes, let's move to the next question now. In the next question, this has been asked, and it's a very direct one. The thing is, final image formed by astronomical telescope. Final image formed by astronomical telescope will be virtual, inverted and magnified, which is a very direct one, theory type, conceptual question. Yes, let's move to the next one. The next one is from which chapter? It's from ray optics. It's on the prism topic. So let us look at how to solve it. I hope everyone knows the formula for refractive index of prism. Using that, this can be easily solved. So refractive index of prism formula is n is equal to sine dm plus a by 2 divided by sine a by 2. So here dm is given to us and that is 60 degree, and we can calculate the value by substituting, and where there we get the value of refractive index to be root 3. From this, using Snell's law, we can get the value of required value of speed of light in the prism, and that answer would come out to be C option. Right. Next, now we have one more question, and that question is from ray optics once again. How do you solve that? The solution is once again the simple one, formula based. So let's solve it. And once you substitute and solve, your answer for this one will come out to be D option, 18 centimeters in the denser medium. So let's move to the next question. Yes, we have next question now with us. The next question is again from ray optics. As you can see it, this question involves the concept of equivalent focal length, that you can write it as 1 by f equivalent is equal to 1 by f1 plus 1 by f2. Using this formula, we can try to substitute the values and simplify it. After further simplification, you will yield an answer. The answer is 40 centimeter, which is our D option. Next, moving to the next question. Next question is from wave optics, which involves Doppler effect concept, which we know is not from the reduced syllabus. So this Doppler effect formula, the formula comes out to be delta lambda divided by lambda is equal to V divided by C. In this, everything is given and we need to find out V. You can substitute, the difference is 600 and 601 difference. Substitute that, and you know speed of light, just substitution. Value can easily be attempted and got it. That would be 500 kilometers per second. Yes. Now next question is from wave optics topic, that is about Polaroids, and it deals with the Malu's law concept. The next question is from Malu's law concept. Malu's law formula is I is equal to I naught cos square theta. So first you need to solve out this one. While solving, what we need to do, this intensity passes through this, we would get an intensity of I naught by 2. The intensity reduces to half. Then once again you can calculate it. When you calculate there, your value will come out to be 3 I naught by 8 when it passes through the second Polaroid. Once it passes through the third Polaroid, our answer will come out to be 3 I naught divided by 32, which is the B option. Yes. Now let's move to the next question, my dear students. Now next question we have question number 13, and once again it's from which chapter? Wave optics chapter. It deals with what? Young's double slit experiment, and it's on beta calculation. We know the value of beta is lambda capital D divided by small d, and as they are speaking, they are talking about electron first fired or electron beam, then they are talking about proton beam. We can easily correct the concept if d and small d remains constant. And how can we connect this concept? This concept is connected to de Broglie wavelength. De Broglie wavelength. So lambda is equal to h divided by m into v. As they have mentioned, speed is same. So speed is same, h is a constant, and m will decide what should be the beta. According to this, if you put up logic and get the answer for this, the answer for this one would come out to be option D. The right option is beta 1 is greater than beta 2. Yes. Let's move to the next question, that is 14th question. 14th question is from dual nature of radiation and matter chapter, and it completely involves the concept of Einstein's photoelectric equation. So Einstein's photoelectric equation, if I use, we know that kinetic energy can be written as energy incident minus work function. They have already mentioned that energy is E and work function is E by 3. Energy is E and work function is E by 3. Substituting this yields us the value of 2E divided by 3. That means this would come out to be maximum kinetic energy, as this is said by Einstein's equation. Since this is maximum kinetic energy, then any photoelectron coming out can have energy maximum of 2E by 3, but below less than that also is possible. So the right option would be 14th. Yes, let's move to the next one. Next question is from, once again, from dual nature of radiation and matter, and it's just a substitution question, substituting and getting the value of the answer. Once we substitute, we would get an answer. That is, I am going to take the formula of work function, phi naught is equal to h nu. Since they are talking about wavelength, so I will just convert it to wavelength, hc divided by lambda, and this becomes lambda naught. This is threshold frequency, threshold wavelength. Once you calculate that, your value of lambda naught comes out somewhere around 5200 angstroms. 5200 angstroms, and the wavelength greater than this, in other sense I am trying to tell you, since I am going to write this in nanometers, so any wavelength greater than 520 nanometers will not give you photoelectric effect, and the only one option that is greater than 520 is 700. Yes. Now let's move to the 16th question. 16th one, this is directly from theory. I would write the formula here for you. Formula is kinetic energy is directly proportional to, kinetic energy is directly proportional to, what we have? Kinetic energy is directly proportional to half, I am going to write half mv square is directly proportional to 1 by d. Using this formula, I can get the answer in a simplest manner. The simplest manner of getting the answer is just substituting the related values, and we will yield up with the final answer of the distance to be d by 4. Yes. Now let's move to the next question. The next question is on a ratio of area of first excited state. First excited state we need to take, first excited state we need to take is the n value, that is a principal quantum number. The principal quantum number for first excited state would be n is equal to 2. So I am going to mention that n1 will be 2 and n2 will be 1 according to that. And you have to find out area. So area would be somewhat like this, A1 by A2. So if you write this, you would get the first excited state is the second orbit, for which you already know the value that it is in this manner, that is the radius of it. So let me write area. Area will be pi r1 square divided by pi r2 square. As we know the radiuses, just I can substitute pi into 4 a naught, Bohr's radius a naught square divided by pi a naught square. Simplification of this one will yield you an answer, and then the answer would be D option. 17th one is D option. Let's move to the next one. What's that? 18th question. 18th question is a nuclei chapter question, very direct one, and which is done with a simple formula of as we know that R is equal to R naught a to the power 1 by 3. This is the radius, and what they are asking us, ratio of volume to surface area. So ratio of volume divided by surface area. Volume means it is a volume of a sphere, and surface area 4 pi r square. Simplifying this and substituting the value of r from here will give you an answer that is nearly same as that of r naught, and the right option for that is D option. So let's move to the next question now. Next question, 19th one is from nuclei chapter, and it is a very direct question which is mentioned in the NCERT book, and at every reaction of this you would get energy of 200 mega electron volt. So 200 mega electron volt. So our answer should be E option for this. Now moving on to the next question, that is the nuclei chapter, which falls in our non-reduced syllabus apart from reduced syllabus. So this question we need to solve it in this manner, that is we know the formula for that, that is R is equal to R naught, we have R is equal to R naught e to the power minus lambda t. So this one we need to simplify it, apply ln for that. If you apply ln, you would get ln of R is equal to ln R naught minus, here we have a minus lambda t. Use this as a baseline for that, that means this line is represented by this straight line equation. Simplify that, when you simplify you would get the value of slope to be, slope of this one would come out to be lambda, lambda is 10 to the power minus 4, and next you can find out the intercept value is ln R naught, which comes out to be 2. Then final substitution of this one in the formula gives us the value, that is here I have to just get the value of this, that is e to the power 2, which is given in the question, that comes out to be 7.5. Then we already know that R naught can be written as lambda into n naught. From this we can get our n naught value, n naught will be R naught divided by lambda. Substitution of this one in the equation gives us a value of 75,000. And here I wind up my discussion for the first 20 questions. The remaining questions will be discussed by my colleague UK sir.
Hi my dear friends, in fact my colleague Arun Sidling sir, he dealt the questions with starting from question number 1 to 20. I am Uttam Kumar Umarji, I am physics faculty from Gurudev PU Science College, Dharwad. I will be discussing the questions ranging from 21 to 40. Now let's talk about this question number 21. If you just note here, depletion region in an unbiased semiconductor diode is a region consisting of, it's a direct conceptual question. So here we will consider option B as our right choice, right? Okay. Now let's move on to next question, that is question number 22. Upper level of valence band and lower level of conduction band overlap in case of. Obviously it's a NCERT straightforward band theory based question. Here we already know that in case of conductors we have overlapping of conduction band and valence band. So very clearly out of these four options, which one is the conductor? Copper is a conductor, so definitely metallic conductor, so hence we can pick option B as our right choice. Moving further to 23rd question. Now this is a typical Ohm's law based circuit that we can consider to be. Now in this particular circuit you can see that they want us to calculate the current through Zener diode. Now note that current through Zener diode is IZ here. So what we will do is we will straight away go ahead and calculate the potential difference across RS. First that we will do. So in order to do that, what we will do, we will consider it to be like PD across RS. Okay, so that I will write it as, or let me mark it here. I will consider this as the current. So this is the current I. Okay, and out of this current I, IL is going out, and IZ, IL and IZ, it is the division of current I. So let us go ahead and calculate current I quickly. Now in order to calculate current I, what we will do, we'll write it like this. I is equal to V naught minus the potential difference of across xenodiode, that is Vz, okay, divided by Rs. V0 minus Vz is what? Pd across Rs. So that divided by resistance Rs. So this is the value of I. Then can you tell me what is the value of Iz now? Iz will be very clearly equal to what? I minus IL. So according to this, we can clearly see that option D matches here, because we have already written the value of I. So hence option D happens to be our right choice here. Okay. Let's push ahead to next question. Question number 24. A PN junction diode is connected to a battery of EMF 5.7 in series with resistance of 5 kilo ohm. So such that it is forward bias. If the barrier potential of the diode is 0.7 volt, neglecting the diode resistance, the current in the circuit must be how much? So here we can directly use this formula. Current I is equal to we have 5.7 minus 0.7, that is net potential difference. So 5.7 minus 0.7. So this happens to be how much? 5. Okay. Divided by what is the resistance given to us? The resistance given as 5 kilo ohm. So I will just write it as 5 into 10 raised to 3. So which comes to numerator, and here we will get this as 10 raised to minus 3. So hence we will obtain this to be what? 1 milliampere. So this is our answer. So in this question, option B happens to be the right choice. I hope you all have followed this. Now let me move on to next question. Twenty-fifth question now. It's a direct question. Dimensional formula of activity of radioactive substance. Now activity is measured in terms of what? Number of disintegrations per second. So obviously it should be what? Option C. C is our right choice here. M0, L raised to 0, T raised to minus 1. Okay. Now let's move on to 26th. An athlete runs along a circular track of diameter 80 meter. The distance travelled and the magnitude of the displacement of the athlete when he covers 3/4 of the circle is. Now note that diameter of the circle they have given. So diameter is 80. Then clearly radius should be how much? 40 here. 40 meter is the radius. Okay. And 3/4 of the circle. So they want us to calculate distance as well as displacement in this case. So in order to find that, what we will do, I will just consider this to be the starting point. From this point we can consider roughly 3/4 of a circle in this way. Okay. I will consider this as 3/4 of a circle. Now we can see that while moving from this point to this point, there is a displacement. Again here we have a displacement, so I can consider the resultant displacement in this manner, right? So I can apply law of parallelogram or law of triangle of vector addition. So very clearly we will get the value as what? 40 root 2 happens to be 40 root 2, because 40 square 40 square. So displacement yes will be equal to what? Square root of 40 square plus 40 square. This is where I can write it as what? 40 into root 2. Okay. So this is displacement. Now distance is very clearly we can calculate it with the help of what? 2 pi r is total distance across the circular track, out of which 3/4. So 3/4 of 2 pi r. That happens to be what? So if we just consider option A matches here, is it not, my dear friends? So we can consider option A as our right choice. So obviously I hope you can calculate the distance, so I am just directly narrating the answer. Okay. Now let's go to next question. Now, in this question, block of certain mass is placed on a rough inclined plane. The angle between the plane and the horizontal, angle between the, I have moved to 28th question or 27th question. Among the given pair of vectors, the resultant of two vectors can never be 3 unit. The vectors are. It's a direct addition and subtraction kind of question, my dear friends. You can consider here 1 unit, 2 unit. Now we can see that their sum will become what? 3. So this is not a choice. This is definitely not our choice. 2 unit, 5 unit. In the subtraction, we will get 5 minus 2 as 3. So definitely here we have resultant may come as 3 unit. So definitely second option is also not correct. 3 unit and 6 unit, again 6 minus 3. We will get what? 3 unit, which is again not correct. So it is not matching. So left option 4 and 8. So 8 minus 4 and 8 plus 4. Maximum values, if we consider 8 minus 4, 8 plus 4, maximum and minimum value, they never come to be equal to what? 3 unit. So definitely option D is the only choice that we have. Okay. Now let's go to 28th question. Now in this 28th question, they have placed a block, and this block is placed on 30-degree inclined plane, and over here they have given us mu s value and mu k value. Both the values have been given. Now you can very clearly solve this problem with simple logic. Now first step what you do is you calculate the acceleration of this block or the net force acting on this block without any friction. If there is no friction, how do we calculate it? We just simply calculate it as what? A is equal to g sin theta. I hope you recall this formula. Okay. A is equal to g sin theta. Now we can calculate the value of g sin theta here. So you can understand, or force F is equal to what here? mg sin theta. I'll just write it like this. Okay. Now this is equal to mg, mass is given to us. So what is the value of mass? Mass m as it is. So I'll just write it as m into g is how much? 10, and theta is 30 degrees. So sin 30 is 1 by 2. We can consider this to be what? 5m. So this is a force. Okay. But according to the problem, there is a friction. They have given coefficient of static friction also. Let us calculate Fs max. That is limiting friction here. Now this limiting friction, we can calculate it as what? Fs max is equal to mu s into normal reaction. Now what is normal reaction? mg cos theta. So hence we will write mu s mg cos theta. So I will just write it as cos 30 directly. Now over here we will obtain the value as 0.6 into m into 10 into root 3 by 2. So here we will obtain this value as something like, this is 0.3 here, 0.3 into 10, it happens to be 3 root 3 m. So 3 root 3 is 1.7 approximately. If we take 1.7 into 3 is how much? 5.4, right? 5.4 is greater than 5m. So very clearly the block is under the state of rest. So hence I will consider the acceleration to be what? 0, and the reason is very simple. Fs max is greater than F. This is how I can clearly answer to this question. I hope it is clear. Now let's move on to next question. So I'll just erase this. Right. Now A particle of mass 500 gram is at rest. It is free to move along a straight line. The power delivered to the particle varies with time according to the following graph. The momentum of the particle. Now this problem I can calculate it with the help of area. We will calculate the area under this graph. Once we calculate that, what we will get? You just apply here power and here we have time. So power multiplied by time you will be doing when you calculate area. Power multiplied by time is what? Work done. So clearly with the help of that, if you just answer, if you just go ahead and calculate the further things, because work done once you calculate, you can very easily calculate the linear momentum with the help of the simple formula delta K is equal to, that is kinetic energy, is equal to P square divided by 2m. Okay, P square by 2m. Now using this formula, if you calculate, you will get the answer as option C, 5 Newton second. Okay, fine. So let's move on to next question now. Now in this question, as the diagram itself is self-indicative, very clearly we can understand that the direction of angular velocity. Now we know that vector V is equal to vector omega cross vector r. We have this vector definition, no? Right? Now if you apply this, I need not even answer. You can directly answer it to be what? Option D here, right? So this is the basic fundamental thing that you please remember. Now let's move on to 31st question. Now 31st question, by the look itself, this problem appears like a goblin, but it is not a goblin, it's a simpleton, very easy one. Now as you can notice, mass of 1 kg is freely suspended. So before we release, what is the velocity of this mass? 0. So initial velocity is 0, no? Right? Then once we release this, its velocity will be under the action of gravity. So for that reason, we can consider here velocity v is equal to square root of 2 into g into h. Now, how did I get this formula? From our kinematic equation, v square minus u square is equal to 2gh, or kinetic energy, conservation of energy, we can apply that also, like half mv square minus u square is equal to mgh. So if you just substitute that formula, we will again get this. So if you just simplify this, we will get the answer as 4 root 2. Okay. So 4 root 2 happens to be our answer, my dear friends. You can make the calculation, you will get root 32 here. Okay. So root 32 happens to be 4 root 2. Now let's move on to 32nd question. What is the value of acceleration due to gravity at a height equal to half the radius of the earth from its surface? Now this again I need not solve. You can solve it very easily because you know this formula, GH is equal to what? GH is equal to G divided by R plus H whole square. Is it not? So if you just use this formula, and if you put, 1 minute, let me just rewrite it. I missed G here, so I will just rewrite it. GH is equal to G into H by R plus H. Is it not? It's whole square it is. So if you simplify this by substituting H equal to R by 2, then you will get the answer as 4.4 meter per second square. So this is the answer, my dear friends. Okay. Now let's go to next question. 33rd question. Now this is based on the chapter mechanical properties of solids. Okay. A thick metal wire of density rho, length L, is hung from rigid support. Okay. The increase in the length of the wire due to its own weight, it's a standard theory type question. This already you have solved in the classes multiple number of times. So I'll just pick the answer as option B here directly. Okay. 34th. Dear friends, if you need any clarification, kindly send a comment. Okay, we will revert back to you. Now, 34th. Water flows through a horizontal pipe of varying cross section at a rate of 0.314 meter cube per second. The velocity of water at a point where the radius of the pipe is 10 centimeter. Now, here they have given us rate of discharge. Rate of discharge is what? Volume per unit time. So, rate of discharge is area into velocity, and this is equal to volume by time. Volume divided by time. They have given us the value of volume by time. As you can notice here, 0.314 meter cube per second. So hence here I will say 0.314 meter cube per second is equal to area into velocity. Area is what? Pi into r square. Radius they have given, so I will just simply mention it, pi r square into velocity. Now simplify this, find the value of V, and V what we will get here as option C, 10 meter per second. Okay. So I have written the basic required formula, you can calculate it. Okay. Then let's move on to 35th question. Now this is a question based on thermal properties of matter and specifically on calorimetry. It is given on calorimetry. As you can see here, a solid cube is given and it is maintained at a temperature of theta naught. It is heated from that temperature to a level called as theta 1, okay, and then it is heated to its vapor temperature theta 2. Then they have given S1 and S2 as specific heats of this substance in solid and a liquid form, okay, and they have given also latent heat of fusion and latent heat of vaporization, okay. So here they want us to calculate the minimum heat supplied, so total amount of heat required in converting the solid into vapor. It's a calorimetry problem. So what is happening, I will just write the logic here, logical steps. First we will get what? Solid. Now the solid is heated. Now to heat, what we will do? We will be using mass of the solid into specific heat of the solid, okay, into delta T, I will say, temperature, rise in temperature. Now it is in what form? Now it has come to what? Its melting point. Now once the solid is in its melting point, then it is heated. Here we will be adding a heat called mass into latent heat of fusion, okay. Then once it is heated, then we will get liquid in the liquid at same temperature of this melting point. Then this liquid has to be heated further to what point? To boiling point. So here again I will consider mass of this liquid into specific heat of the liquid into rise in temperature. Then now this liquid reaches to its boiling point. So here I will say liquid at boiling point, okay. Now when the liquid is at boiling point, now to convert this liquid at boiling point to vapor, okay, I will be adding a heat of M into what? Latent heat of vaporization. You sum up all these, you will get option C, is it not? Okay. So third option happens to be the right choice. So I have shown you the steps in converting a solid into vapor. So you just apply these symbols accordingly, you will get the value, right. So this is 35th question that we have answered. Now 36th question. Now this is again based on fine. Now this is based on PV graph. Now as you can notice here, we have net pressure 3 P naught minus P naught, that is 2 P naught. And what is the volume change here? 3 V naught minus V naught, that is 2 V naught. What is the product of these two? 4 P naught V naught. So option B is our right choice. Let's go to 37th question. Ratio of molar specific heat of oxygen. Such a silly question. Oxygen is diatomic. What is the specific heat? What is the value of gamma for diatomic gases? I need not say. Correct? Molar specific heat of oxygen. Oxygen is diatomic, so directly we will write 1.4. Then talking about 38th question. 38th question. Now here we can see that for particle executing simple harmonic motion, okay, at its mean position. Now this is your board exam MCQ question, dear friends, is it not? Okay, it is option B, no, velocity is maximum and acceleration is 0. So option B. 39th question. A motorcyclist moving towards huge cliff with a speed of 18 km per hour blows a horn of source of frequency 325 Hz. If the speed of the sound in air is 330 meter per second, the number of beats heard by him. Now in this question you can very easily answer to this question by using beat frequency FB is equal to apparent frequency minus frequency of the source. Okay. Now this apparent frequency and frequency of the source. Now you will get this apparent frequency as V divided by V minus Vs into F. Okay. Frequency of the source minus frequency of the source. If you just key in the values, you will get the answer as 10 beats per second. So it happens to be option C here. Okay. Now let's go to 40th question. Question number 40. It is based on a body has a charge of 3 minus 3.2 microcoulomb, the number of excess electrons it has. So should I solve this? I don't think so, but my pick is 2 into 10 raised to minus 13. So excess electrons, and they have given you the charge. Simple thing, no? I hope you can follow the solution very easily. And dear friends, I have completed 21 to 40. Okay, so next 41st to 60th question, it will be discussed by my colleague Shri Nagaraj Durganavar sir. So I would be taking a leave, and if you have any queries, kindly go ahead and send us a comment. We will revert back to you. Thank you very much. This is your friend, teacher Uttam Kumar Umarji.
Hello, welcome everyone. I am Mr. Nagaraj Durganavar, physics lecturer working in a Gurudev PU Science College. Welcome. So I am going to continue the CET question paper discussion of physics 2024. The question number, previous question number was 40, that is answers 2, and 41 question, which is based on the first chapter electrostatic, and that is a point charge of plus 10 microcoulomb. There is a plus 10 microcoulomb and another one charge of plus 20 microcoulomb are placed at a distance of 1 meter. So here plus 20 microcoulomb exert a force on 10 microcoulomb and 10 microcoulomb exert a force on 20 microcoulomb. This will be F1 and this will be F2. Both are having the same magnitude but which are in a opposite direction. Hence you can choose answer. This is both are same forces but acting in the opposite direction. That's why the option is B. And next question, moving towards ahead the question, that is 42. A uniform electric field. This is question number 40 and this is 41st question. Uniform electric field E, which is equal to 3 into 10 to the power of 5 Newton per coulomb, is acting along the positive y-axis, then electric flux through the rectangle area 10 centimeter into 10 centimeter, that is EA, area is 10 centimeter into 30 centimeter area, whose plane is along the z and x axis. So that's why 3 into 10 to the 5 Newton per coulomb, and which is acting along the positive y-axis. Question number 42, sorry, 42, this question number is 42. So the flux area is whatever we have, that flux formula is EA cos theta. So here what is theta? So here plane is parallel to z axis whose area vector is along y axis, hence theta will be 0 degree. If theta is 0 degree, flux is equals to EA. Just you multiply these two, you are going to get the answer as this much. 9 into 10 to the power of 3 volt meter. Now the question number 43. The total electric flux through closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is. Suppose, see, this is question number 43. There is a closed surface in which a dipole is there. A dipole consists of one plus charge and one minus charge. So what is the net charge included in this closed surface? The net charge is 0. If charge is 0, where is the point of flux? So therefore directly your answer is 0. Yes. Next, we will move to the question number 44. Under the electrostatic condition of charge conductor, which among the following statement is true? If you see the first option, the electric field on the surface of a charge conductor is sigma by 2 epsilon, which is the application of Gauss law. So here it is not applicable. The electric potential inside a charge conductor is always 0. No, whatever the charge potential will be there on the surface of the conductor, the same is inside the conductor also. Therefore this is also wrong statement. Now any excess charge resides on the surface of the conductor. So when you charge a body, whatever the charges are there, all those charges resides on the surface of the conductor. So that's why this is the correct answer, that is C. Yes. Next, 45. A cube of side 1 centimeter contains, see there is a cube, the question number 45. The volume of that cube is 1 centimeter, which is 10 raised to minus 2 into 10 raised to minus 2 into 10 raised to minus 2, which is equal to 10 to the power of minus 6 meter cube. This is the volume of a cube. So in that 100 molecules are there. So here n is 100 and dipole moment of each dipole is given by 0.2 into 10 to the power of minus 6 coulomb meter. Yes, an external electric field also they have given, that is E is equals to 4 Newton per coulomb. The electric susceptibility of the material they are asking. So electrical susceptibility we can give the formula as susceptibility is equal to net dipole moment divided by electric field. So if you calculate that electric field and net dipole moment, you will get the answer. So net dipole moment will be n times of individual dipole moment upon volume divided by electric field. So if you calculate this one, all data you have here, if you calculate that, you are going to get as 20 and the electric field will be 4, therefore which is equal to 5 Newton, that is 5. So answer is B. Now we are moving towards the question number 46. So question number 46 is that a capacitor of capacitance 5 microfarad, that is 46. What is the capacitance of a capacitor? That is C is equal to 5 microfarad, which is 5 into 10 to the power of minus 6 farad. Next, it is charged by a battery of 10 volt. At an instant of time, the potential difference across the capacitor is 4 volt. So here potential difference is dV is equals to 4 volt, and the time rate of change of potential difference across the capacitor, that is dV by dt. dV by dt is 0.6 volt per second. The time rate at which the energy is stored in the capacitor, time rate they are asking. So dear friends, that is we know that potential energy stored in a capacitor is half CV square, and they are asking time rate of change of storing the charge, that is du by dt is equal to, if you differentiate this, this will be half C as a constant, V square is as a 2V into dV by dt. So here you cancel 2, put the value of C, put the value of V and dV by dt. After substituting all these values, you will get a 12 microwatt is the answer. Yes. Next. Yes. So the next question number is 47. 47 question is based from the chapter current electricity. We have derived this equation that J is equal to sigma into E. If you rearrange this one, we can write like this: J is equal to 1 by rho into E. So by rearranging this one, electric field is equal to rho into J. So which is a possible equation now? So that is C option. So from this J is equal to sigma into E derivation, we have got this equation, that is option number C. Now we will move towards the next question, that is question number 48, which is a application of Wheatstone bridge. So I will try to draw the Wheatstone bridge here. So this is a Wheatstone bridge. So if all are the same resistor R, so based on that, if this P by Q is equal to R by S, so suppose if I give the name as P, Q, R, S, then P by Q is equal to R by S, then it is said to be bridge is balanced. Under balanced condition, this resistance would be cancelled. Therefore, so you can write the answer, this one as resistor as finally this is R, R, R and R. This can be written as two R and 2R, and these two are parallel, hence the resultant answer is just R. So like that, so this complete will be R and this will be like that 2R. This is R, this is 2R. Total in series, that is 3R. So I will solve this one here. This is total 3R. And this current is I, and here it is grounded, therefore potential is 0, and here it will be V0. Therefore net current they are asking, right? What is the current individual, right? I is equal to net potential is a V0 minus 0 divided by total resistance, that is 3R. So this is the answer. That's why our option for question number 48 is D, V0 by 3R. Yes, we will move towards the next question, that is question number 49. So in this one, they have given current along the y-axis and time along the x-axis, and they are going to said us to calculate the number of electrons. So first we calculate the charge, then we can calculate the number of electrons. To calculate the charge, we have a formula, that is Q is equal to I into T. So here I, which is given along y-axis in terms of milliampere, each division will be of 100, 200, 300, 400 like that it is. So it is 100 into along x-axis, that is each division is 5 and milliampere is 10 raised to minus 3. Like that, total number of divisions you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, and these two half are there. Therefore, we can consider total number of 10, that is into 10. Now this will be total 5000 into 10 to the power of minus 3. Now later, by using the formula quantization rule for a charge, that is Q is equal to plus or minus N into E. So for here N you have to calculate because number of electrons they are asking, which will be Q by E. So here Q is equal to 5000 into 10 to the power of minus 3 divided by 1.6 into 10 to the power of minus 19. So this, if you calculate, that you are going to get 3.125 into 10 to the power of 19 electrons. Therefore, the answer is 3.125. Question number 50. Question number 50. So here the graph is given. So here we should take the first graph as 100 degrees Celsius, second graph as a 400 degrees Celsius. So here we can get the slope of this graph. I by V will get the resistance. R1 is equal to, and we have a formula 1 plus alpha into T1, and R2 is equal to 1 plus alpha into T2. Now if you divide, you will get that. So this will be tan, because we are going to calculate the slope, hence we are calculating the tan value, tan 45 and tan 30. So R1 is tan 45 divided by tan 30, which is equal to 1 plus alpha T1 divided by 1 plus alpha T2. So if you solve this one, you are going to get the answer as A. The option is A, 50th one. Now next 51 question. An electric bulb of 60 watt, 51, a bulb of 60 watt, this is power, which is operating at 120 volt, voltage of the bulb which is 120 volt, source voltage which is 220 volt provided for whole the things. Now you have to calculate the series resistance for the operation of bulb properly. For that reason, first we calculate the current in the bulb. How much current in the bulb? So IB, using the formula power formula is what? P is equal to V into I. Then what is I? P by V, that is P by V. So power is 60, voltage across the bulb is 120, so which is 0.5 ampere is the current in the bulb. Now next, you should calculate resistance of the bulb. What is the resistance of the bulb? Again from this formula or Joule's law of heating formula, we have a resistance is equal to V square by P. V square by P. By substituting this value here, we should consider voltage of the bulb. So this is 120 whole square. You will get 14400 divided by power is 60 watt. So now you are going to get this as 240 ohm is the resistance of the bulb. Now you need to calculate like this. Suppose this is a bulb and this is a resistance which we need to connect in the series, and we are providing total potential of 220 volt. So this is a bulb, this is a resistance, I will take it as a small r, and this is a current I. So here voltage V is equals to total voltage current into total resistance, I will consider as RS. So here IB is already we know, RS is what? So RS is equal to resistance of the bulb plus R. So which is 0.5 plus, sorry, not plus, it is into. So this is 0.5 into 240 is a resistance of the bulb plus, sorry, 240 plus small r. Now if you solve this one, you are going to get the answer as 200. Next. So here it is based on the meter bridge as well as Wheatstone network application. So here P by Q is equal to R by S formula we have to consider. That I will write as 52. That is X, I will take this one as a X what they have given, divided by S, which is equal to L divided by, as it is a 1 meter which is 100 centimeter, that is 100 minus L. Correct? Now first we will take X naught initially at X naught, and they have taken the S as same, which is given by 50, at that time 50 divided by 100 minus 50, which is 1. Now similarly the X resistance at 100 degree Celsius, and they have kept the S as same, then it will be 60, that is 100 minus 60, which would be 3 by 2. Now divide these two terms, divide. So after dividing you will get X naught divided by X 100, which is equal to 2 by 3. Now instead of this X 100, if you substitute X naught divided by, like we have one formula, R is equal to R naught bracket of 1 plus alpha into delta T. So like that, so here it will be X naught bracket of 1 plus 1 plus alpha into change in temperature is 100, which is going to be 2 by 3. Now X naught cancel. If you can calculate the alpha, that alpha is equals to 0.005 degree per coulomb. So this is your answer. Where it is? Yes, this is option C. Now next 53, a moving electron produces, this is a question from electromagnetic waves. If electron is moving, it not only produces a magnetic field, along with that electric field, both it consists. So accelerated charge particle produces electromagnetic waves, hence the answer is B. Both produces both electric field and magnetic field. Now next 54th question. Now next 54. So here magnetic field is directly proportional to square of the coil number. Therefore you can write B1 upon B2 directly proportional to N1 upon N2 whole square. So by applying this one, B1 upon B2 is equal to N1 is 9 upon N2 is 3. If you read the question, it is squared, 3 get cancelled, which will be equal to again 9. Now if they are going to calculate B2, they said us to calculate the magnetic field in the second coil, as B2 is equal to B1 by 9. Therefore the answer is first option. Next 55. A particle specific charge of Q by M. So this is completely based on application. So here the charge is Q by M projected from the origin towards the position x axis, with a velocity 10 meter per second, uniform magnetic field is taken in the downward direction because minus k. See, consider Fleming's left hand rule, correct? So in this one, if you consider the downward direction, correct? So minus k where it is? So this is x axis, y axis, z axis. If you consider like that, it is minus k, negative direction. So if this is x, y axis, this will be negative y axis, like that. So here, by seeing that, your electron should move in the negative direction. Hence, in all of these questions, the negative direction only is given in the option number C. Therefore, option is C. Now, 56th question. The magnetic field of the center of circular coil of radius r carrying a current of I is 64 times of the magnetic field at a distance of x on the axis from the center of the coil. The value of x is, they are asking the x value, distance. Yes, question number 56. They are saying that magnetic field is equals to 64 times of the magnetic field, right? Therefore, we know the magnetic field formula, that is mu naught into r upon 2r. Sorry, mu naught into I. Mu naught into I upon 2r, which is equal to 64 times mu naught into I upon 4 pi 2 pi I r square upon x square plus r square, x square plus r square raised to 3 by 2. This is the formula. Then here mu naught I 1 2 get cancelled, then 2 pi also here get cancelled. Therefore, your formula will be become x square plus r square raised to 3 by 2. If you take this term at this side, and this is equal to 64 r cube. 64 r cube. X square plus r square raised to 3 by 2. Yes. So I forgot here 3 by 2. Then taking the cube root on both sides, we get x square plus r square, which is equal to 4r. Now if you solve this one, we will get x square is equal to 15 r square. Then taking square root on both sides, x is equal to root of 15 r. Yes, therefore we get the answer as root 15 r. Next, 57. Magnetic hysteresis is exhibited by. Magnetic hysteresis is only exhibited by the ferromagnetic material. See, paramagnetic and diamagnetic, they do not exhibit magnetic material, only ferromagnetic can be exhibited hysteresis loss. Next, magnetic susceptibility of magnesium at 300 Kelvin is 1.2 into 10 raised to minus 5. What is its susceptibility at 200 Kelvin, they are asking. So here the susceptibility formula is for a magnesium is Curie's temperature, that is C by T. Now we can calculate this one as susceptibility of first one magnesium divided by susceptibility at second temperature M2, which is equal to C is constant, only inversely proportional to temperature, hence we call it as temperature 2 upon temperature 1. Now here we need to calculate the temperature 2, therefore susceptibility of magnesium at 1, susceptibility of magnesium at 2 into T1. So already they have given the susceptibility of this one, that is 1.2 into 10 to the power of minus 5 So into here temperature, we need to calculate the susceptibility, right sir? Susceptibility, that's why we need to calculate here x mu 2, xm2 upon T2 into T1. So T1, T2, if you substitute, you are going to get this as 1.8 into 10 to the power of minus 5. So that is 1.8. Option C is the answer for that. Next, question number 59. Question number 59, if you observe that it consists of one hemisphere. So here magnetic field is 2 millitesla and exists vertically downward. Here the magnetic flux, whatever it is entering, the same number of magnetic flux pass through. So if I consider here like this, so instead of this there is another hemisphere is placed, the number of magnetic field lines coming inward, the same number of magnetic field lines will go outside. Hence first we calculate the magnetic flux for this surface 1, which is equal to BA cos theta. Here area vector and angle magnetic field lines, it is a 180 degree, theta is equal to 180 degree. Hence BA cos theta is minus B into area is pi r square, and they are given the radius of this hemisphere and all those things. That's why minus magnetic field is how much? 2 into minus 3 pi, and radius is, here we have to consider this is 10 by root pi is given. They have not given any unit, but the unit, if you consider centimeter, then only we are going to get the answers. So here they have to give the unit as centimeter. Therefore it is 10 divided by root pi, 10 by root pi centimeter square. Then after calculating all this, that is minus 20 into 10 to the power of minus 6 Webers. This is for hemisphere. If you remove this cone by another hemisphere, there is no difference. So whether which kind of shape is present, that is not important. This number of magnetic field lines, how many they are coming out. The how many number of magnetic field lines entering, the same number of magnetic field lines should come outside. But for this cone, if I consider, then the direction will be opposite. So minus of minus, it will become positive. Hence magnetic flux for a cone surface, that is S2, will be plus 20 into 10 to the power of minus 6 Webers. So the answer is A. And last question, that is 60th question. So here the current is in the x-axis, positive x-axis, and the ring is falling downward. So you have to consider like this rule, right? Thumb rule. So thumb represents the direction of current, and in that there is a ring is falling where magnetic field is produced. Magnetic field is produced like the what? Towards your face. So towards our face, what we can write here? Circle and dot. Then it will be, magnetic field will be coming towards you. That's why here the whatever magnetic field induces, that will be like this. So this kind of magnetic field induces, then here the current will be clockwise. Therefore the only one option is correct in this one, that is C option. Thank you very much. If you have any queries, you can send a comment in the comment section. We will guide you. Thank you.